Okay, so in this video we've again got the data for thinking distance, braking distance and stopping distance here, okay? But what I want to do now is show you how to calculate the reaction time or the thinking time, okay? So remember, the thinking time equals the reaction time, okay? They are the same thing. There's no difference, okay? Now, what we need to be doing here then is this. We're going to calculate the reaction time or the thinking time. So we need an equation, okay? So time, if you remember, is equal to distance over speed. So your thinking time is equal to the distance divided by the speed. Now, let's do this for a speed of 9 meters per second first. So there's your speed. It's got to be in meters per second, okay, if we want the time in seconds. But the question is, what distance do you use? There's 3 different distances here, or actually there's only 2 different distances, but you get the idea. There's 6 meters for your thinking distance, 6 meters for your braking distance, and 12 meters for your stopping distance. So which one do you use? Well, we're trying to work out the thinking time. So you need to use the thinking distance, which in this situation is 6. 6 over 9 is obviously going to give you 0.6 recurring. Now, do not forget, you must write either the recurring symbol above, or you must write you could write 0.67, or you could write 0.7. I would probably do it to 2 decimal places, 0.67. But do not write 0.66, okay? Because that's not correct. Next thing then, let's do the same thing now for the thinking time. Let's work out thinking time again, but this time we'll do it for 13.5 meters per second. Okay, now which distance are we going to use? Again, it's got to be the thinking distance, so that's 9. Now, what do we think about the thinking time? Is it going to change when we speed up? Well, we've already said this earlier. No, it's the same. At every speed, it's the same, okay? So if you do 9 divided by 13.5, surprise, surprise, you get 0.6 recurring, so 0.67, let's say. Okay, we'll do it one more time. Okay, this time we'll do it for 18 meters per second. Okay, so it's going to be something divided by 18. And again, we need to use the thinking distance, so it's 12 over 18, which again is going to give us 0.67 seconds. Okay, so the thinking time is the same for all of these speeds and distances, or it should be, okay? If there's any slight variation in here, it's because when I converted these from miles per hour into meters per second, I probably rounded it, and that might affect it. But I think they should be the same for most of those, okay? But if you use the correct data that's not rounded, it's definitely going to be the same for every one of those speeds. Now, this is useful because it now allows us to work out this thinking distance here. Now, you already could have worked it out, okay? We know that every time this speed goes up by 4.5 here, okay? Or in some cases here it's going up by 5, isn't it, okay? Again, that's down to rounding. But when you see these speeds increasing here, okay, every time these speeds increase, you can see that the thinking distance is going up by 3 meters, okay? And again, let me just stress this. The reason that this is going up by 4.5, and then this is going up by 4.5, but that's going up by 5, and that's going up by 4 there, okay, and so on. It's all to do with the rounding as I've gone through here. So sorry about that, okay, it's just rounding issues, but they are going up by equal intervals when they're not rounded. Right, so the point is, you can see the pattern here. The distance is going up by 3 meters every time, so that should be 15. But let's just confirm that, okay? So the thinking distance here is going to be equal to, distance is equal to speed times time. So the speed here is 23 meters per second, and we're going to multiply that by the thinking time, which we know is 0.67 seconds. So let's work that out. So you can then do 23 times 0.67, and that's going to give you 15 meters, okay? Again, because of the rounding issues here, it's not exactly 15. You get the idea, okay? But that's 15 meters there, okay? So what we're saying is that if you know the reaction time, you can work out the thinking distance at various speeds. Okay, and once you know the reaction time for one speed, you know the reaction time for all of the speeds. Okay, so be aware of that. Once you know the reaction time for one speed, you know it for all of them.